Hello boys and girls, and welcome back to this tutorial on how to create a room escape game in Unity. This is Flag Games, and we're going to continue with the scale puzzle. And this is the last mechanic that we're going to need in order to be ready to set up the game and then start playing it. So I'm going to explain a little bit how this puzzle will work. The player has to balance the scale, and he gets 5 spaces here that he has to put a block in it. In the game, the player will have 5 blocks, but for this example, we only need 1. So the player drags this and put this in a preferable space that he needs, that he thinks that matches, in order to balance the scale. And just for a quick explanation, I'm going to show this so that you how this works. So the player will have in his disposal the numbers 1, 2, 3, 4, and 8, and with these numbers that will be displayed as blocks here, he has to solve this puzzle. He actually has to balance the scale. So how this is solved is you put 1 here, 2 here, 4 here, 8 here, and 3 here. So this number is multiplied by 2, and this by 1, and this by 1, because this point, it only the distance from this point is 1 unit, and this is 2 units, and this is 1 as well. So this result is 4, this result here is 4, and this result here is 4. So this section is balanced. Now the whole weight of this section is equal to 7. So this 7 multiplied by 2, because we have 2 units here, if you see these black dots. So it gives us the result of 14. And in this section we have 8 multiplied by 1 and 3 multiplied by 2. So this gives us also the result of 14 if we put this together. So this is how this puzzle is solved. Pretty simple. Okay, so how the mechanics will work is the player will click on a block and we'll start dragging it. And for that we'll have a very useful mechanic in the event system library of Unity. There is an interface that allows us to drag objects with simple coding. So we will drag this object and put it wherever we see fit. And when we drag it, in order to place it here, we drag it and then we leave it. So the moment we leave it, we drop it. The moment we drop it is the moment that we will check with our system if the mouse is inside of any of these boxes here. So when I take this block and leave it here, drop it here, I'm going to check if it's inside this box. So if it's inside, it will drop in this box, or if it's not inside a box, whatever it is, then it will turn to its initial position. And when the player will have every block in a specific place, we will check to see if the blocks are in the correct place. So this is how this mechanic will work. Okay, so jump back in Unity. Let's just make this happen. We're going to the display image and going to walk3, because this is where the scale puzzle is placed. Set everything to inactive, and we need a new render object, which will be wall 3, and put this here and this here. Okay, so now in wall 3 that we need to put it here, wall 3, in wall 3 we need a, let's go to the prefabs and put a change view object. I'm going to not zoom in this specific place and just change the view. I'm going to do like in this mode, because I want it to be a new image, so it won't be much confusing, because in this display state we will have UI objects, and it's preferable that we render it in a different image, so there will not be many objects overlapping with each other. So this change viewpoint needs sprite name, and this will be in the resources, so we'll put the scale here in the sprites, and then put this scale here. So wherever we click, where is it? Wherever we click, not there, but about there, with a bigger box collider, maybe about 2. Yeah, wherever we click in this box here, we will change the view and we get this image right here. So with that said, we need to create another render object with it, which will be the scale. And of course put it here. Yeah. So let's set this active to false, and let's focus on this one. Let's go to canvas and create a new empty game object and call it scale. Okay, maybe with a capital. Inside scale we need the UI image, and in this UI image we need the sprite that is the block, like this, and maybe scale it down. We need to match this approximately with these spaces here in these block boxes. Okay, like this, about this size. Yeah, it doesn't match perfectly, but it will be fine. We can stretch it so it actually fits in the place. It's in your choice, you can do whatever you want. So we have one of that, and let's call this block. And as I told you, blocks have specific numbers upon them, so we need another image, and for this image we call this the number that this block contains. What happened? Okay, yeah, it's because this overlaps with the child overlap covers the parent. Okay, so we had the where was I think, yeah, here we have the numbers, so it will be pretty easy to put some numbers here. So for this one we'll put the 1, and maybe size it down a little bit like this, and just going to duplicate one more time, and one more time, and one more time. So we have 5 blocks, and for this block we need a different number. We need 2, we also need 3, we need 4, and we need 8. These are the 5 numbers that the player has in his disposal. Great. And one more thing that we need is in the scale. In the scale image, we need to put the positions of these boxes here. So create empty and give it a box collider, not box collider, but box collider 2D. Give it a box collider, call it box, maybe scale box, whatever, let's call it somehow that you see proper, and put it here and adjust, put the sender in the center of the box and adjust the box collider. The box collider will be about this. Yeah, it's fine. And we need to adjust this because when we hover over the mouse here and we give the position of the mouse, we need to see if it's inside this box collider in order to define if we drop a block inside a box here. So we need 5 of that as well, and put them in places. Let's put them in order like this. We begin with this one here, the second one here, so it's going from left to right. And here. Okay, so we have all the positions that we need in order to make this work. So what do we need? Let's start scripting. The first component we need is the block component. And let's see how we're going to make this box here draggable. So I'm inside the block script here, and what we need is using the event system. Wait. I just got a new keyboard and I'm still adjusting to it. Event systems, right? And we need the interface that is called I pointer. I don't remember. Wait a minute. Okay, so the interface we're looking for is the iDrag handler, and we need to implement this function onDrag. And onDrag is a function that will execute whenever we click on a block and hold clicking, and we actually drag it. So we need a vector 3 new position. So we actually drag the block wherever the mouse is in wall space coordinates. So it will be screen to wall point and input mouse position. Great. And so transform position of this object will be new vector 3 new position x new position y, and we don't need to change this set position. Cool. So let's see if this works. Hopefully it does. Okay. In order to see this, we need to put a component support a block component in these blocks here and hit play, and we get the display here for now, but it's fine, and we can drag it and let them be wherever they are. Okay, so this part of coding works. Let's continue. Let's create a new script and call it, of course, scale. We need the script as well. We load this and scale. We're going to load the positions of the boxes, positions of the spaces here. So the public game object scale box positions. I'll just call it scale box because we're passing the game object, no, the transfer of the game object. So in scale here, let's put this component and drop this. Drop one, two, three, 4, and 5. Great. Okay, we have that, and what we need to do next is go here in block and implement another interface. This will be iDrop handler, and for that one, iDrop handler again. I said iDrop handler, and for that one, we will use it to throw the block inside the box. So whenever we drop it, so whenever we stop clicking, we're going to find the scale with a capital that contains the position of the boxes we are looking for. So let's call it scale, and let's call a for loop or int I equals 0. I is less than scale get component scale, and the object we're looking for is scale box is the length I++, and so let's verify if our mouse is inside the box collider of these boxes. So if this will be a long scripting, so I'm going to pause it and come back when I'm done. Okay, so I'm done writing. I created a new variable, mouse position is like at 1, and we get the position of the mouse in world coordinates. And then, from basic algebra, we can check to see if our mouse is inside the box collider. So you know how it works. Get the mouse position X, and then we get the position. So it's actually the X position of the box, and then we get half size of the half width of the box collider for the positive, and then for the negative. So we need to check every side the boundaries of both the right side and the left side, and then from above and below. So it's actually copy paste everything. You just need to change the x and y values and these inequality symbols and the width and the height. The width and the height. So to show you that this works properly, we go here and I debug log whichever scables we are inside. So for now I just debug it, I don't do anything else. And now, instead of debugging, let's put the block in the correct place, in the center of the box, that is. So transform to the position of this block is equal to this. Position. And let's just do this like this because we don't want to change the X position, you never know. Y and will be the same Z. Okay, so let's give it one more shot. Like this, yeah. So you see, I drop it just on the side and it goes in the center. So that works fine. Okay, so you know that these blocks should only be available to the user, to the player, whenever this scale image is displayed. So in order to do that, of course we will need a private game object display image. You already know what we do with this. We put in a start and we find this game object. Game object find, not with a small but a capital. Game object find display image. Display image. That's right. So create a new function called display. And actually we won't do this inside the block component, but inside the scale. And you understand why. Is because when we need to set the display, we need to set them active and inactive in order to hide the display of the blocks, but we can't do them inside the blocks component because when the object is inactive, the block functions are not called, so it won't work. So inside the scale, we're going to create a private game object list, and this will be with the private game object. Okay, we need a private array of blocks, and then we initialize it like this. Find objects type block. So we have all the blocks here in this variable. So in the display, if display image get component display image, if the current yeah, if the current, no, not get component display image, but can get component sprite renderer, and we need the sprite and the name of the sprite, and if the name of the sprite, so if the display sprite is the scale, we will do a for loop for every block. Every block will activate. Blocks, blocks, I selected game object, selected to true. Okay, here we have the scale as a display. Please set them active to true, or else do the same thing but deactivate them. That's right, and don't forget to put it in the update. In this update, for a display function, and I believe that everything will work fine. But we will need one more thing, and this is in the start deactivate self, because the scale is inside here, so it won't be rendered in the start, because the starting image is the wall one, right? So it won't work for the initialization the scale script. So we're going to deactivate them when we start the game, and from then on the scale handles the job of displaying these blocks. I think this will be okay. Okay, for some reason here, yeah, for some reason I deleted. No, there wasn't anything here. Never mind, I thought I did a mistake, but I didn't. So let's see if it works. We're here, and yeah, it works fine, right? So the last thing we need to do is just verify if the scale puzzle is solved, and when it does, we're going to switch this image to this scale open. Preferably I would like to name it scale solve and name it like this. Then we'll put it in the resources because this is necessary, and now it will be simple, I think. The way to do this is by creating another public int and call it weight or correct weight or just weight. How to call it? Call it correct weight or weight? I'll call it, yeah, just call it weight. Weight like this. Okay. So we need to put the right value of every box here that it demands in order to be correct. So for this box here we need 1, for this we need 2, for this we need 4, for this we need 8, for this we need 3. So this is the correct weight, or just weight, or whatever you call it, it doesn't matter. So we will initialize this by going here and public int weight is the new int of 5, size of 5. So wait a minute. Okay, so we got it. So we have an order from left to right. So if you remember, it's 1 here, this one is 2, this one is 4, the other is 8, and finally we have 3. Okay, so these values correspond to each of the boxes here. And now, we need to go to the scale here and create a function called verify solution. And in order to verify this, we need to know where each block is currently placed, in which box. So in order to do that, we will need a public index of box, yeah, just that. So whenever we drop it, and we drop it in a box, it will get the index of this box. So it will be I, because if you remember, we have the correspondence of the values here. So we have 5 boxes, and we have 5 weights. So from 0 to 4 for every box, we have a correspondence. How is the correspondent? We have the correspondent value of weight, and that means the block number. So, and for blocks, we need to know the corresponding box that the current block is currently in, if you get what I mean. So when we drop a block here, for example, it will tell the system that the block is inside box 0, or here is inside box 2. So everything will be clear in the end, so don't worry. We send the index of box to I, and we initialize this with -1, so that means that at the start of the game, every block is outside of the boxes, they are in the initial position. So back to the scale here. Back to the scale. In this verify solution function, we're going to verify if every block is in the correct place. So let's see. Okay, for that we need one more thing, and this would be in the block component. We need a public int correct box index, and this is the index it should belong to. And for that, let's make it a property, get and private set, get and private set, and we initialize this with 1. Index of box equals actually 0, 1, -1. Okay, don't worry, fear not, because we will make it right if you are lost in what we're doing here. So we need the for loop for int I equals 0. I is less than scale boxes length, and I is plus. We also need a flag let's make it bool. Bool verifier solution with a bool flag of solved equals to false. Actually equals to true. And now we iterate for every block, and blocks I. Actually, this is an if condition. If blocks I have the index, if the index is equal to the correct index, correct box index. Actually, if it's not equal, let's set this flag to false. Set it to false. So, and then return. So you see, I believe what it does is it verifies that every block is in the correct place. And if it does, it goes to the update. And for now, just debug logs that it's solved. Debug log scale puzzle solved. Great. What? It's a faxing, right? I want to believe that everything is okay and it will work. So the block here with 1 have the correct box index of 0 because it belongs here. This belongs here. Oh wait, this belongs here. This belongs to here, like 4, and this is here, so 2, and the 8 is here, so 3, because this is an index and it goes from 0, 1, 2, 3, and 4. Okay. Let's see if this works. So I'm putting everything in the place it should be. And yeah, I get here the puzzle is solved. Okay, so a couple of things to do is one thing is whenever we drop it and it's outside of a box, we need to return to its initial position. So initial position, of course this is this new keyboard. This is vector 3. Come on, this is vector 3, and the initial position is the position in the start of the game. So in order to do that, we also need the flag here. Bool dropped inside of box equals false. And if we drop it inside of a box, then this equals true. Equals true, but if we don't, then we need to return it to its initial position. So transmit position equals to initial position. and the index is equal to -1. Okay, this is one thing, and the other is when we solve it, we need to change the sprite, change the display, change the image, call it whatever you like, to this one, the scale solved, and inside the scale solved, it will be the hidden item that we want. Okay, I hope you are with me till here. It is quite long, quite hardcore scripting, or maybe not, but it's a long process. This video has been a while, so we're close to the end, hanging there. We have the scale solve render object. We will put it in the scene manager here and take this here scale solve, put here, and you see this black hole that opens whenever we solve it, and we will find the 8 claps here. So for that we need to set this to pick up item. The display sprite is 8 claps. 8 claps, and this playable item. It has a box collider to it, box collider component, and make it smaller, and then rotate it like this, and put it here, and put it in this render object. Okay, so pay a little attention here, because it demands a little bit of concentration in order to understand exactly what is happening. So look what we're going to do. In move 3 we have a change viewpoint that gets us the scale. We're going to rename it as scale display, maybe. I think let's call it scale displayer. Okay, so when we solve it, say, is the scale solved? Is it solved? We need to do some things here. One thing is, when the private bool is solved, and is solved equals to true here. Okay, so when it's solved, I don't want to drag the blocks again. I leave them where they are. That's one thing. And so it will be if game object find, we need to find the scale game object, and the component is also the scale. The scale component, and we need the is solved. And now that I think of it, it should be a public bool is solved, get private set and we initialize it with false. Okay, so we go here and we get the is solved, and if it's solved, then return. So okay, If the scale is solved, no block will be moved again. And the other is, okay, the other is, look here, in object find, I'm going to find a scale displayer, as I told you before. Scale displayer, I'm going to find that object and get the component of that object, and the component of that object is change view, and it's what did I call that? Is sprite name, and is equal to scale solve. So from now on, this view change view object will display this image, the solved image, because you know when the player solves it and then exits this image and then go there again, we don't want to display the not solved image. You get what I mean? We need to display the current state that we have, and that is this this black hole that had already opened. Okay, so with that, another thing comes up. It's this. So we also want this to happen. We also want these blocks to be displayed when display is this. Okay, hopefully you understand that. And one last thing is, take this here and load, you know what, load sprite, and the path is sprites scale solve do. Okay, we are very close to the end, or maybe this is the end. Maybe everything is fine now. Let's see. Hang in there. We're almost done. Put everything here. This one and this one and this one. Null reference. Where do we get a null reference? Okay. Okay, I know. We can do this like this, because at the current time we try to find it is inactive, so we're going to do this with a public access of scale displayer, like this and like this. Scale displayer get component. Come on, change view, and this is the sprite name, like this. It should be. So we're going here, and drop it here. Let's see if that works now. Okay, put this here, put this here, this here, this here, and this here. Okay, it works, but we need to set the layer here to 1 and take it. And we got to get the display because we don't have it in the inventory items. We need to put this in the inventory items, and now everything is okay. So that's all, guys. I hope you didn't get exhausted of this procedure. It was quite a long edit. Oh, one more thing is left. And the thing that's calling the issue is this. We don't really need to call this verify solution every time, because if it's solved, is solved, if is, or and, okay, now I found what I wanted to say. If verify solution and is not, it's not really equal to, it's not solved, then call it, because it's not, if it's solved, we don't need to update it every time and set the sprite to this to scale solved. So with that done, I hope everything works, and we have to place, get the card, and get out of here, and we're done with this. Okay, so that was maybe a hard one, maybe the hardest in terms of perception. It was quite difficult for me to, in order to set it correctly and sufficient so it doesn't mess up with the whole other scripts. So you see that as we move on, things get a little more complicated because you have many more variables you need to, you need to control. So you need to have that in mind whenever you do something. You need to set the right basis, examine things, and have everything optimized so you don't have problems in future. So now we have everything. We need every mechanic. We don't need any other scripting. Okay, maybe a little, for the escape condition, but everything else is ready. And now we only need to set the room. So we will play with solve the riddles in the correct order and find the key in order to escape. And that is all. So the next time, I hope, hopefully in a few days, we will have the next video and this project will be complete. So thanks guys for watching, even though this was a long and hard one. See you next time. Bye.